Thank you. Thank you for the introduction. I hope that you can hear me. So my name is Thierno, and I work as lead data scientist as BAMTU. And I'm here today to present to you some of our works in the WOLOF language, especially we'll focus on speech recognition here. So we will talk about the motivations of the project and also the goals that we aim to have here, and some of the challenges that we have faced across the route and still facing some of them. Also, we'll talk about an overview, let's say, of the algorithm and models that we are using. I wanted to do a demo, but we can't because I can share my screen directly here, and also conclude with some take home and the next steps that we will go through. So let's talk first about the motivations here. I think we have many motivations, but let's just talk for some of them. So the first one is we have a high penetration rate of new technologies here. I mean, most of people here have a phone and they are using Facebook and also stuff. But the thing is, those applications are in foreign languages like English, French, and so on. And I mean, I would say, I think 50% of the population don't speak in Senegal, for example, they don't speak English nor French. So they can't really use those applications like other countries are doing because they can speak the language. So that's a barrier for us. Like some of our fellow citizens can't use all the functionalities of Facebook and WhatsApp, for example, because they can read. Also, there is a lack of application of artificial intelligence techniques on our local languages, like systems like machine translation, speech recognition, or even speech synthesis. For example, if you go to providers like Google or Amazon, for example, they don't have any of these. Any of these are supported for our local languages, but they work for French, English, and so on. So that's why that's the motivation here. And the goal is to have, as I said, more accessibility to new technologies for our population, like being able to interact with connected objects or using application with voice like Siri or Google Voice, and not be limited by their language. Also, there is the thing that we want to facilitate the interaction between people speaking only our language and people speaking foreign languages like English. So that's why we want to build like translating stuff, like being able to translate books and, for example, articles written in our language or written in the foreign languages, so that everyone could get the information from the other. Also, we want to put our local languages on the map of artificial intelligence, of course. Okay, so as I said, we want to have a complete system. So what we want is not just speech recognition. So what we want is being able to get audio and process it, have text, do some language understanding, and also give the response with audio. Why do you want to have audio in the input and audio in the output? It's because our language, WOLOF here, even if it's written, the thing is most of us can't write correct WOLOF. Like me, I can speak WOLOF very well, but I can't write WOLOF correctly. So that's why we want to get as input speech, do the processing to get the text. And for example, if we want to translate, we can translate. And then if we want to get some information, we can get it by like getting entities like persons, localization, and so on. And then give the response to the user by doing speech synthesis. That's why, because people also can't read correctly WOLOF. That's why we want to have input as audio and output as audio also. And as you can see, we have many challenges to face here and many systems to build to have this complete system here. So the first challenges that we have here is really about data, as you mentioned it. So, I mean, we have very little data in WOLOF or in our local languages compared to what you can have in English and even in French. So we need a data collection platform to be able to collect data for each of the tasks that I just mentioned. So we need people to create text data, but also audio data to be able to build the whole system here. We have also some challenges with respect to materials, because you need, as you know, lot of compute to be able to build these models, GPU, CPU, and also RAM. And fortunately for us, we had some collaboration with some cloud providers like AWS and also Microsoft Azure and even Google that helped us to be able to train some of our models. But still, we do need more of that. So let's talk about how do you build a speech recognition? So you have a complete pipeline here. So first you have your audio, but then you need an acoustic model here. I mean, you have the processing of the audio, of course, which is not here, but you need an acoustic model that can link audio, so raw audio, to phonemes or even to tokens, depending on the kind of model you're using. And let's say if you use something like phoneme models, you need also to get those phonemes and then move it to and have words. And then once you have word or token, you can call it whatever you want, because these may be subwords or even characters. Then you need also a language model that can help you to correct your acoustic model, because acoustic model will make some errors. So having a language model will help to correct those errors and give probabilities, I mean, higher probabilities to sentences that are more frequent in the given language. And then you have your sentence as output. So this is the whole pipeline for speech recognition. And then you can return the text. Now, to build these models here, you have many algorithms doing that. I just present a few of them. So we have the recurrent neural networks, because language is sequence. So for example, if you take speech recognition, you have an audio. So it's just like a sequence of real numbers. And then you need to process that sequence. And for that, you need an algorithm that is able to take the context that is present in the sequence. So that's why we use stuff like recurrent neural networks, where you have your models, and then where you have your inputs coming, like X0 here, is processed by the recurrent neural network. Then you have an output, but you have two outputs here. So you can use the output from the X0, so from step 1, as input to step 2, and also the token, so in the sequence, for which is here X1. And then you use that to have another output, and so on and so on. So this kind of model help to model the sequence in the data. And with NLP, everything like is sequence here, even with translation and even with speech synthesis, you'll have sequences. So that's why this kind of model is handy for this kind of task. Now, we have also other models. So for example, here you have a framework which is called sequence to sequence, and it's really one of the framework, if not the framework, for doing anything related to sequence as input and sequence as output. Because if you take a human, that's how we do. If you want to do speech recognition, I'll have to wait for the person to give all the sequence, maybe not all the sequence, but some part of the sequence, but not just taking one real value and trying to, or 2, 3 real values and trying to give the text. So I need to anchor first the input that I have, and then from that, I have all the information I need, and then I can give the output. And that's what sequence to sequence model are doing. It's just taking all the input, process it, try to understand before trying to get the output from the input. Now, for example, if you take an example with translation, for example, I think it's easier to explain it with that. So you have, let's say, a French that you want to translate, les pauvres sont diminués en français, and then you need to go to the English. So you first process all the input text from the French sentence, and then your decoder will take that encoding, and sometimes with attention also, to try to give the output. And that's exactly how a human translates sentences. You don't just take one word and try to translate the word from the language from the source language to the destination language. You first process all of it, and then you try to get the output. And that's why these models, this framework is really working well. It's not really limited to recurrent neural network. You can also use this in other framework or other models like convolutional neural network and so on. And we will see next how we use this with transformers. So transformers can process sequence, but it does that differently with respect to recurrent neural networks. Because here you don't take input step 1 and then you take step 2 and so on. You can take all of them, but then you will try to see how each of them is related to the others by using self-attention. So in a nutshell, that's how transformers are working, and then you can have many blocks of those, and then you can have your output. I'm presenting this because for now, the model that is giving us I would say the best result is based on transformers. So that's why I think it's important to present it. And even in text NLP, this model is one of the best actually. So this is how it works. So I don't have the animation here, sorry for that, but you have your input coming. So here's the 3 étudiants, and then you can process, you can embed them, and then you take the embedding, you try to model the positions, because since you are taking all of them in once, you need to know which one is at which position. So that's why you need that embedding with time signal there. And then you have your encoder. They will try to encode the input step by layer by layer, and then you take that encodings to your decoder, and your decoder will try to give the response. The only thing is that here you don't take the input step by step, you take all of them, and that helps also to be able to parallelize the processing of the input, and then have a lower time to predict to have your output compared to LSTM, but you need to orchestrate the infrastructure for that. So as I said, for now, we have to make, I mean, we tried many models. It's not like just we have to take. We tried TALD, we tried also the recurrent neural networks and so on. But Web2Vec is the one that giving us the best result. It's because Web2Vec can be used easily with transfer learning, because Web2Vec here is first trained with big corporate like Facebook here to be able to, let's say, to have a good representation of the audio coming as input. So it uses self-supervised learning. That means that you don't need label to train the pre-trained model. So you just need audio. So this one, we use the one that is trained in multiple languages, 53 languages. And while training the pre-trained model, all they do is they take raw audio without any labels, so no text, and then they give that to the model. So the model has first CNN layers, and then it tries to represent the audio, but then you have transformers that we just talked about that try to model the context also that is in the audio. And it will just mask some part of the audio, and it will try to predict those parts. So that means that if I can predict the part that's missing, I have to have some knowledge about the context around that part that is masked. So that's how it works. So after that, it has a good representation of any given audio, and then you can just take that audio and give that representation, to a classification layer, which is here just the fully connected one, and that's how it works. So all we did was to to add that classification layer to predict our WOLOF audio to text. So this one is really the one that is giving us the best result for now. And as I said, I would like to give you a demo because we are pretty satisfied with what we have now in terms of speech recognition in WOLOF using this model Web2Vec. I mean, we have still work to do. We have to collect more data and so on, but this was really a big boost to our results that we were having before using Web2Vec. So that's thanks to the guys who open sourced this one here. So if I were to give you some take home, or also the next step that we will develop and we will try is first data. So I would say that data is really the fuel that we need the most here, because I mean, is in any machine learning model, most of them, I would say, having more data really help, but in speech recognition, it's more, let's say, it's very important there to have a large amount of data set. If you take models like Google models and so on, the models that they are giving as API were trained like in stuff like 1,000 hours of data. And for now, we just have about 24 hours of data. So there is a big difference here. So that's why we also need real transfer learning here. But having that, it really helps. So for now, we are having some issues to collect more data because you need money also, because you need to pay people to collect the data. And I would say that machine learning is an iterative process. So we started doing this I think for about two years. And every time we try to ameliorate, so we see what do we need to add? Do we need more data? Do we need to use new models? Do we need to modify the models that we are using? Stuff like that. So we are doing this iteratively. So it takes some patience to be able to have good results, especially when you have when you don't have a big team or you don't have the resources needed to collect data and to train models very frequently. But as I said, we have some promising results here with our different, our last experimentations. The thing is also WOLOF is easier than some of the language because I mean, in WOLOF, what you hear is what you write. So, you know, you don't have difficult stuff like in English where you can see a word like true, but it's written in a very different way than what you hear. In WOLOF, you don't have that. So that makes easier for some time when working with forums and so on. But what makes WOLOF difficult is that it is a mix of other languages. So when people say speak WOLOF, they also use English inside, Arab inside, French inside. So that makes it difficult because the assumption that I gave you that WOLOF is what you hear is what you write. That changes when you put stuff like English or French word. Also that changes because you don't have enough data to model those inputs and to model the switch between languages. That makes it really difficult, especially in the different or in the other tasks, like in the translation part. It's kind of easier in speech recognition. So also, I want to say that the linguist people really helped us a lot in this because we don't have the rules. For example, let's say a simple one is how do you convert text from WOLOF to phonemes? That one we had to work with some linguists to build the program that can do that because you need that when you do stuff like text to speech, for example, and even in speech recognition for some models. So as I said, for the next steps, I think we need better algorithm in low resource environment. I think people are working on this, like Web2Vec here. I think those are the one that really can help, I mean, transfer learning in a nutshell, because having an algorithm that can work from scratch with low resource for now, it's like, we don't have it now. So it's like a dream. So few short learning models for now, they are not that good. So I think transfer learning is what we need for now. And that's what worked for us also here. And also multilingual learning, like models that are trained in many languages at the same time, so that they can learn many stuff from the different languages, especially for languages that are similar. For example, WOLOF is part of the Congo languages. And so having data from also those languages and train a model that use all of them can also help. And as I said, self-supervised learning also is something that we need to explore in WOLOF, I mean. So like training Web2Vec models just in raw WOLOF speech data set, because we have many of them like in YouTube or in other platforms, but they don't have any text related to them. But at least we can use self-supervised model to train models like Web2Vec to have a good understanding of WOLOF, because the Web2Vec model, for example, that we use didn't have WOLOF in the training data set. It had 53 languages, but WOLOF was not part of there. So using collecting raw data in WOLOF without any labels and then train our own models, our own supervised model will give us better result for sure, because the model will be able to represent better audio from WOLOF. And as always, collect more data and continue iterating to have better results for our models. So here I just presented the speech recognition part, but as I said, we're also working on translation, also on text-to-speech, to have the overall system that people could use to build stuff like chatbot in WOLOF and so on. So that was all for me. So as we say in WOLOF, Direjef, and thank you for your attention. And if you have any questions, don't hesitate.
Thank you, Thierno. I really liked your presentation. It talks to me personally because I worked on the Swiss-German dialect, also implementing speech recognition services. So I see a lot of reactions from the audience. Unfortunately, I'm gonna be able to only ask one question because time is pressing. We have positive reactions. So first question is, for how long did you train to get a good model?
Okay, so I mean, if you talk just about the best model that we have for now, it didn't take time. Like it's just transfer learning, so you just need to train your last layers. So I would say the model could be trained in about 2, 3, 4 hours. I would say I don't remember the numbers, but as I said, we are working on this since 2 years. So you need, I mean, we needed to learn many stuff throughout the route to be able to get this from to get the results that we are having now.